So now we just now we move on to the geotechnical considerations when we are addressing the problem related to scour under marine structures. The type of soil supporting a coastal foundation governs the scour protection, scour or erosion potential and the long term behavior of the foundation of that particular structure. Loose granular soils are rapidly eroded under the movement of water, flow of water, while cohesive or cemented soils are more scour resistant, as we all know. So that is one of the reasons why we use natural rocks as scour protection. Sandy soils will be eroded earlier, not only earlier, it will be eroded in more rapidly also compared to the other types of soil like bedrock, etc. So sandy soil, sandy beaches, when you want to develop, in case you want to develop some promote some kind of infrastructural facilities on a sandy beach, then you better be on the watch out for the scour. Again there is a difference of scour and erosion. Scour is a kind of a local phenomena, more intensive with respect to the local near the obstruction, but erosion can be felt over long distances. Next, soil properties. So properties of sediments which are very important in the phenomena of scour. Scour is governed. These are the characteristics of the sediments which control or govern the extent of scour. So namely the particle size, particle shape, sediment concentration, fall velocity, specific weight of particles as well as grain size distribution. Apart from a few other characteristics, if you want to have a detailed information on this, you can go to my lecture on sediment characteristics, wherein we have discussed most of the aspects and some additional factors also, or you can refer to a number of references books given at the end of the lecture. The threshold of movement, that is where your hydrodynamic shear stresses exceed the seabed shear stresses, that is going to depend naturally on the particle size, the density, shape, packing, orientation of the seabed material, all these factors, they control the threshold movement, that is the initiation of sediment motion. Under ways we have worked out a few problems also on initiation of sediment motion. So look at the informations that have been discussed under the chapter on initiation of sediment motion. Soil types affecting scour. The percentage of soil types with scour problems are listed below. It is seen that the sand foundations have 48% of scour problems, while silt foundations do not display any scour problem. So percentage is given on the right hand side and the sediment size is given on the left hand side. So sand has the maximum percentage. All these informations are available in the list of references that are given at the end of the lecture material. Soil types affecting scour depth. The intensity and duration of current will affect the rate of scour in the seabed. The following table represents the duration of maximum scour depths in different soil conditions. Some of the scour depth which are used are local scour depth, ultimate scour depth. The ultimate scour depth is the depth beyond which is almost like steady state once you reach. So, some of these informations can be had from a number of references. I am not going to discuss about all those details. Duration for maximum scour depth in different soils are given here: sand and gravel bed materials in hours, cohesive bed in days, glacial tills, poor cemented sandstones in months, hard dense well cemented sandstones in years, and granites in centuries. Now, scour depth depends on the following parameters: diameter of the sediment size, I mean the grain size or the diameter of the sediment, diameter of the obstruction, that is in this case we are considering a pile, hydraulic gradient I, D is the water depth, U is the mean velocity of the undisturbed flow, and U star is critical velocity given as this expression G into D naught into I square root of this product as mentioned by Bruces et al. In 1977. So, the critical velocity is represented as a form of the water depth, as a function of water depth and the hydraulic gradient. The hydraulic gradient is going to be the driving force. Now, let us look into the scour due to currents. Most of the empirical relationships that are available in literature are based on experimental work. The experimental work, I mean in the laboratory, is not so easy, because modeling the sediment is not so easy. You can easily model the flow, but modeling the sediment is a bit tricky and it is not so easy. This is an equation or a relationship available for the prediction of scour depth as given here. SP is the scour depth, dP is the diameter of the pile. Now, this is given as a function of relative water depth H by dP and the Froude number and Froude number at the incipient motion, which is governed by, this is the undisturbed velocity for which you calculate your Froude number, and the other one is based on the flow field at the incipient motion. So, once you are able to calculate all these variables, if it is available to you, you can estimate, I would use rather estimate, because all these things are derived from experiments and it is an empirical formula. Then sediment scour depth in cohesive soils under currents. So, this is the relationship as given here. This alpha c is the product of these numbers, and all these things are, u is the velocity, d is the water depth, and d is the capital dP is the pile diameter, then tau c is the critical shear stress, and all these variables are given to us. So, based on this you can estimate the scour depth under cohesive soils. Scour under piles caused by wave action. This is basically a function of Culligan-Carpenter number. Culligan-Carpenter number is U max T by D. So this equation is quite straightforward, but it is valid only for Kc number greater than 6. Scour under piles due to combined action of currents and waves. So you have a beta parameter coming here which is controlled by this factor, where UP is Ursel's parameter, this is Froude number, this is Reynolds number, this is wave steepness. Once you are able to calculate this, then use this relationship to get the scour depth. Now we having seen some of the basic starting with the basic phenomena of scour, we saw what are all the problems associated with scour, the importance of scour, the consequence of scour if you do not consider the scour protection, what will happen to the structure. Then we looked at the combination of environment as far as flow is connected. So you can have a steady current or waves, combined waves and currents, etc. And finally we came up with, we looked at the formulas for current, all these conditions, different conditions. We also looked at the different soil characteristics that are very important. I am sure that this lecture should be a starting as a base for you to, if you are interested in proceeding further in this area, this can form as a base material. And of course additional reading is very much essential in order to understand in order to really do some kind of research or in the case of field application. So now we will move on to scour protection measures. As I said earlier, is a very important aspect to be considered for the construction of any marine structure. Protection is chosen based on the type of structure and its importance, location of the structure, availability of material, what kind of materials are available, and finally the most important is the cost criteria. We have a wide range of products that could be thought of, but a careful planning is needed. Broad classification of protection measures. The scour protections methods can broadly be classified as rock fill method, riprap method and protective mattress. Scour protection measures, the measures can be actually the details I have presented the details here. It can be either protective apron like the apron near the toe of the dam, rock dumping for bed stabilization, mattress, this mattress can be geosynthetic mattress. Look at some of the look at the lecture on geosynthetic materials, the application of geosynthetics in coastal engineering. That will give some information about the protection, scour protection. Then trenching, this particularly is very important in the case of pipelines, or and even in the case of I would say even in the case of breakwaters, if you have excavated toe, you need to have a kind of a trench wherein you can place your toe although difficult, it is extremely effective. Then sandbags or grout filled bags, this is the most commonly adopted. It depends on the environment. For example, if you have a location where you have a lot of sharp corners, sandbags is not a recommended procedure. Anchoring of stops and soil anchors, flow energy reduction device including artificial seaweed. So now there are some geosynthetic products where you can have a seaweed growing. So this is this can result in a rich flora and fauna also. There are options, but naturally when you want to have more benefits, the product is going to be costly. So you have to decide what exactly you want. Soil improvement to increase soil bearing capacity and to reduce cover potential. These are all soil improvement studies, ground improvement techniques. So there are a variety of problems and methods also. So you have on the top the types of structures. This I have taken from Richard Whitehouse from his book Scour on marine structures, around marine structures, piles, pipelines, large volume structures, sea walls, breakwaters, jack-up rigs. These are the variety of structures that are in existence in the marine environment, in the ocean or in the coastal zone. So on this column you have the type of the method for protection. Protective apron for piles, large volume structures, sea walls and breakwaters. Rock dumping can be used for all, but of course the size of the rock will be varying. Then mattress can be for pipelines. In fact, mattress is widely used for pipelines, widely used, and in fact we had a very nice experience of lowering a pipeline in a water depth of 20 meters, where the velocity of water was approximately 9 meters per second, 8 to 10 meters per second. This is somewhere in Gujarat, along Gujarat. So you can imagine with this kind of a speed, the pipeline is resting on the bed and we need to have a protection for the pipe. So we looked at several options, and finally we went in for this mattress. Unfortunately I do not have any pictures on this. So what was the main problem is not even the anchoring. The main problem was dropping it and making it, keeping it in position because of the huge velocity involved. So this has been completed and the pipeline is in its position without any problem for at least now maybe about between 5 to 10 years. So then sandbags, there are several cases. In fact it is also used in the case of sea walls and breakwaters also, although it is not marked here. Flow reduction in all the cases we have. Then soil improvement scheme, mostly piles, large volume, sea walls, etc. So you see that there is a pile structure here, how it has been protected. You see that this is the kind of protection. So the width, a height, all these things need to be calculated. Or you can have a stone revetment in order to prevent the slope erosion or slows the cover around this, and you can also have vegetation here which is strongly recommended. This is for the case of a pipeline, you have a kind of a mattress. This is a application of geobags, offshore wind plants, wind energy plants, which is gaining tremendous importance these days. So when you operate, when you go in for wind farm, this is one important area where we need a lot of information. Scour protection forms a basic necessity. Then this is in case of a pipeline, this is only a partial protection, you protect only this portion, probably in deeper waters, because if this kind of a situation exists in shallower waters, the ship anchors etc. might hit by chance. So in case of mostly this kind of situation, this kind of protection is considered, the whole pipe is covered. Protective mattress, as I have said earlier, this is a prefabricated mattress used where less control over rock dumping, they are flexible and follow local bed contour. So those are the advantages. So a synthetic, it is also Fascine, this is another product which was which has been mentioned in Hebisch et al. So filter fabric strengthened with geosynthetic natural, this is nothing but your natural your geosynthetic material, and you have a strengthening so that it is very flexible, you can cover it and use it for. So this is another block mattress, a continuous array of concrete blocks held together by cable and then it is laid over the concrete block. See, for example, you look at this, this is to take care of end cover. So this is vertical walled structures, sea walls, as I have told you, these are used by using gabions. See, scour and erosion, they are together, in fact there is a slight difference, but the effect is almost same, effect is loss of material. So with this I will conclude, and I would just like to list the books. All these references have provided some useful information on cover under marine structures, and these are all some of the references that I have used in preparation of this lecture, and there might be some others also which I might have missed.